a few terms that we have here to talk about that we've used. We've used these words before, so there shouldn't be anything new. The first one is a variable. Okay, when I use the word variable in math, what I'm talking about is letters. Right? Typically, the letters that we use are X and Y. Those are our variables, but it could be any letter. Variables can change. Right? So the letter X represents any number you want X to be. So X could equal 1, X could equal 2, X could equal 3.5. Right? It could equal anything you want. And that's called a variable, something you've heard before. Another term that we're going to have to talk about is operations. Operations means adding, subtracting, dividing, multiplying, exponents, all that jazz. Okay, and we're also going to have to talk about the words and what each one means. So, for instance, the word add sometimes is used as the word sum. Right? I'll write down a few. Add is sum. I typically just use the word add, right? Or plus even, which is really not a good phrase to use. But hey, that's okay. The word subtract. Anybody know what the mathematical word is for that? Give it a shot. Yeah.
Difference?
Yeah, it is. It's difference. Good job. Okay, so if they say the difference between something, we're talking about the subtraction of it. So the difference between two numbers, that means one number subtract the other number. The word multiply. I want to take a stab at what multiply is. Yeah, it is. So multiply is the product of two things. So if I say the product of two numbers, I'm talking about the multiplication of two numbers. Anyone want to take a stab at divide? Yeah. Yeah, divide is quotient. We ran into that one on a quiz, I think, early on in the year. And people were like, what's a quotient? Quotient means you're dividing two numbers. I don't think I have any fancy number or word for exponents. Maybe you hear it as like to the power of. Maybe you hear that. Sometimes you hear squared, right? That would mean the exponent is 2. Or cubed, that would mean the exponent is 3. But there's no fancy word like what we have here with sum, difference, product, quotient. Again, you might not need to use those words at all, but it's probably just a good reminder that those operations all have a term that go with it. So if you ever read it, you know what's going on. Awesome. An expression. An expression is just a mathematical statement that doesn't have an equal sign. So, for instance, if I had 2x plus 3, that's an expression because there's no equal sign in it. If I said y equals 2x plus 3, that's an equation because there's an equal sign in it. So this one, expression. This one, equation. Again, just terms that you're going to hear throughout like your math life, right? Like you're going to hear me say things in the future in math 10, math 20, math 30, where I'll say the expression or the equation, and it does mean something specific. Those words don't just interchange, although sometimes we tend to do that. Most of the things we work with are equations, meaning that you can solve something. Awesome. Independent variables, dependent variables. We've already talked about these before as well. Independent variables, I like to call the input. So if you had an equation such as this, y equals 2x plus 3, this is the independent variable or the input value. The one with all the numbers around it. We call our independent or our input. The other variable, the one that's by itself, We call that the dependent variable. I often refer to it as the output. So this guy is the output. A good way to remember which one's which. If I told you an input value, if I said, oh, x equals 2, then I could calculate this, and it would give me an output. But if I said, hey, you want an output, a y value of 2, I wouldn't be able to just calculate my input. And there'd have to be a lot of math that goes on. I'd have to move the 3 over, move the 2 over. It would be a lot of work to find the input value. So x is my input, because if I put in a value, it gives me an output instantly. Other way around, if I give you an output, it's a lot of work to find the input. You're working backwards. I've used those terms before early on in the unit. You maybe have forgotten, but I did use those terms that x was input, y is output. This means on a graph, if this is x and this is y, my x variable, or the one that goes horizontal, is my input. And my y variable would be my output. Or independent dependent. This also means that if we had a table of values, the first column is my input. My second one is my output. I think that's everything we've done. Oh, there's one more. We don't usually talk about them like that, but ordered pairs. Technically, or remember, ordered pairs are like this. X and Y. That means technically this would be my input. This would be my output. It's a lot of ways to express math. Right? We have equations, graphs, table values. We have ordered pairs. We have lots of ways to describe graphs. Or just relationships between some sort of information. Okay. When trying to figure out what quantity is the independent, which is the dependent variable, complete the following sentence. The dependent depends on the independent. Why is it? This is weird. It already filled it in for you. It's not supposed to be there. So it's the dependent variable depends on the independent variable. Let's try a question. It's the best way to do it, I think. So example 1, we got Luke works to earn money this winter shoveling driveways. He wants to know the amount of money he will earn, A, based on the amount of hours he will work, H. Luke will get paid $10 per hour. So in any word problem, when it gets to things like this, they're going to define 2 letters for you. In this case, the 2 letters are A and H. I think it's smart to write out what each one of those letters means, because from question to question it changes, and sometimes it can be hard to tell which one's which. So when we're looking at A, he wants to know the amount of money he will earn, A. So A is how much money he makes. I write that on my page. And this is a habit that I continue from grade 9 to grade 12. Every single word problem, I find out what my letters are, and I write them. So I'm going to say A equals money made. Then I'm going to look for the next letter. It says, based on the amount of hours he will work, H. Hours he will work, H. So then I write to myself, H equals hours worked. That's how I do it on a regular question. I actually write it out physically like that. The two quantities being compared are, we're going to put it into fill in the blanks, are money, which is A, and hours worked. Which is H. You're not going to have those nice fill in the blanks, right? So it's smart to know how to do it in another way. If you think about this question logically, which thing would be the independent variable and which thing would be the dependent variable? Yeah, the hours are the independent variable, right? Amy said that the hours worked would be the independent variable, which makes sense because the amount of money you make is dependent on how many hours you work. Right? That's how the best way to think about it. Which thing is dependent on the other? The amount you make is dependent on how many hours you work. So we're going to say the amount you make it's not you make, the amount Luke makes. The amount Luke makes depends on the hours he works. So now we have two things that we're doing on every single question. The first thing is we figure out what each letter means. The second thing we do is we figure out which one's dependent, which one's independent, especially with word problems. The independent variable, we've already decided, was H. The dependent variable was A. We're going to try to complete a little chart now to figure this out. So they've put their independent variable first, H. They put their dependent variable A second in the column. And they've already filled out the first five H values. We're going to figure out which values go in the other column. So according to this question, if he worked 1 hour, how much money would he make? $10. How'd you get that? Yeah, it does, right? It says right in the question, Luke will get paid $10 per hour. So he works it used to be. So if he works 1 hour, he gets $10. If he works 2 hours, he would get $20. If he works 3 hours, he would get $30, $40, $50. And you notice that it's going up $10 every single time he works another hour. When the independent increases by 1, the dependent variable increases by 10. This means the relationship between the dependent and the independent variables is 10 to 1. The way we represent that is by saying 10 times the number of hours worked. Right? That's how you'd figure out how much money they made. If you work 20 hours to figure out how much money you make, you go 20 times 10. If you work 2 hours to figure out how much money you make, you go 2 times 10. That's the expression. To make it an equation, we have to have an equal sign. Our equal sign would be A equals 10 times H. With this equation, now we can figure out how much he makes. So if you look at H and I, H says if Luke works 12 hours this week, he will earn. So I look at my equation. My equation says A equals 10H. They told me 12 hours. That means I can change H in my equation to be 12. If you put that in your calculator, you get A equals $120. So we built an equation. We then use that equation to give it an input value and find an output value. If you look at question I, they don't give you an input value. They give you an output value. They said that Luke earns $160. That means A equals 160 hours. Sorry, $160. That'll be a lot of hours. So when you go to your equation, this time you're going to change A to be 160. So that now you have this. 160 equals 10H. I went to my equation. I changed my A to be 160. My goal now is to figure what H equals. The way you figure what H equals is to get H by itself.
Wouldn't it be 100? Wouldn't it be 16?
It would. And some of these equations are easy that you can just like solve them in your head. They will get too hard to do that. So you're going to want to know the process to do it. So if you have this situation and you're trying to figure out what H equals, that means you're trying to get H by itself. To get H by itself, you need to move this 10 to the other side somehow. The way we would move that 10 is by dividing it. If you divide both sides by 10, it'll cancel out on that side. On the left side, 160 divided by 10 is 16. And then you have H. Not bad. So as we do word problems, you're going to create equations. Then you're going to use those equations to figure things out. Either your input or your output, one or the other. We're going to try another example together. So example 2. This is a landscape designer manufactures square garden plots that use wood boards as edging in a herb garden. That sentence is awful. The square plots may be aligned in a row. The number of boards B is related to the number of plots P. So if you look, they've got all these square gardens represented. The first one is just one square. That one square has 4 boards. Right? 1, 2, 3, 4. Let's see. If you look at the second one, that one has 2 squares, but it has 1, 2, 3, 4, 5, 6, 7 boards.
Would it be? Right now.
It's not 8 because they share one of the boards now. If you were to do 3 plots, how many boards is it? Yeah, there's 10 boards there. And if you looked at 4 plots, it's 13 boards. And you might have been counting them all out. You might count them out, or you might notice that there's a pattern that all they're doing every time is they're adding 3 boards to get an extra plot of land. And so if you wanted another little plot, you would just build 1, 2, 3. Right? That's all that's happening.
How many would that be then? I think it's sarcastic.
Part A, the two quantities being compared. So again, we always want to know what our two letters are. We have the number of boards, which is B. And the number of plots, P. I usually write it out as an equal sign. So I say B equals boards, P equals plots. One of these is the dependent, one of them is the independent. If you're not sure which is which, think about what's dependent on the other. Joy. Yeah, the boards is dependent on the plots, right? You're going to decide how many plots you want to build, and that's how many boards you're going to need. So that means your boards are the dependent, your plots are the independent. So the quantity of boards depends on the quantity of plots. We're going to build a nice little table of values for this. Your independent goes in the first column. So our first column is P for plots. Our second column is B for boards. We're just going to fill in the first four plots. So we're going to say 1 plot, 2 plots, 3 plots, 4 plots. And then fill in our B values, which we already know, right? So we need 4 boards for 1 plot, 7 boards for 2 plots, 10 boards for 3 plots, 13 boards for 4 plots. Part D. When the independent increases by 1, that means we go up 1 plot. How much is the dependent variable going up by? 3. Right? And that's what we talked about earlier. Like if you added 1 plot, it's 3 more boards. All right, we're going to try to create an expression for this. Now, the mistake that people would make is they would say, well, this is 3 to 1, which is true. It is 3 to 1. So they would say that their expression is 3P. But that's not actually true. So if you think about it and you tried 3P a few times, if P equaled 1, 3 times 1 is 3 boards. You actually needed 4 boards. If you tried P equals 2, 3 times 2 is 6. 6 is 1 short of our 7. Yeah, so you notice you're coming up 1 short every time, right? So you're going up by 3s. So that part is correct. But what you need to do is add 1 more board because the first plot needed that first board to start your pattern of 3 adding on every time.
So you just like add whatever you need.
Yeah, so you can add whatever is needed to fill it in. When you have a table of values, the coefficient or the number multiplying comes from whatever this increase is. It's going up by 3 every time. That's going to match up with this. But it doesn't start at 3, right? You started with 1 board and then put 3 around it. This is your start. Where this one is your rate of increase every time. Kind of like what we talked about yesterday. Now, we're not going to graph it right now, but we could now graph this situation as well because we have a starting value, a y-intercept, and a rate, which is a slope. And so we could graph these things if we wanted to. That's only an expression because there's no equal sign, so we're going to make it an equation by saying that b equals 3 times p plus 1. That is now an equation. That equation can be used to solve anything I want. So try to solve the next two on your own. Joey, talk me through G.
You times 7 by 3 and plus 1, which equals 22. Or you do the pattern way, but it's not.
Yeah.
Times by 3 and 1.
Yeah, you're absolutely right. Yeah, so he said you take the number of plots times by 3 and add 1, and it was 7 because it said 7 plots. So 7 times 3 plus 1 would work. The mathematical way of showing your work, in any given question, they should tell you one of the variables and ask for the other. By saying that there's 7 plots, they're telling you that p equals 7. So you need to go to your equation and change the letter p to be 7. When we change things or we substitute them in, we use brackets like that. Yeah.
If I want to do h, can I divide and subtract?
Yep, you'd subtract first, then divide.
Yeah.
Yep.
Wait till you subtract first.
Yep. So remember, you move away the additions, subtractions first. So you'd have to subtract first, then divide.
I thought it was like backwards. Or not backwards, like, so you like flip it, so it's the opposite thing. Just like you multiply, so you divide.
Oh, yeah, you would. So you do subtraction.
You make 34 divided by 3 minus 1.
Right, but you have to do the minus 1 first. So you do 34 minus 1, then divide by 3. So back on this one, you substitute one letter in, which we've done, and I did it in red. Then you're going to put this in your calculator. And that will tell you what b equals. In this case, b should have equaled 22. Hello. All right, that's the mathematical process of doing it. If it's a written response question, that's what I want to see. I want to see the substitution, then calculate it. The other one's harder. The other one's harder because it gives you the dependent variable. So if you look at it, yeah.
If you minus 1, then you can easily tell that it's 1 above 30 and 3 times 7 is 30, so just 11.
Spot on. That's exactly what we're going to do. So when you read the question, they should give you one variable. In this case, they said 34 boards. So they told you b equals 34. So you go back to the equation you built and you change the letter b to be 34, and everything else stays the same. So we have 3p plus 1. Now your goal is to solve for p. I understand that some of these questions you could just count it out and figure out what it is. You could probably guess and check and figure out what it is. You could just do the patterns and figure out what it is. But I'm warning you, these questions are going to get too difficult for that. So you're going to have a mathematical process to solve for p. That process is getting p by itself. Maybe we do bed mass in reverse. So we need to move things away from p. Yep.
Is there any parts in this where we cannot use editing, like for tests?
Yeah, probably. So when we're getting it by itself,
Wouldn't it be samded?
yeah, it'd be like Sam did. Yeah. So when we're doing this in reverse, and we're getting something by itself, gentlemen, when we're getting a letter by itself, we want to do reverse bedmass. So you want to move any additions or subtractions away as your first step. So I need to move that plus 1 as my first step. And the opposite of plus 1 is minus 1. So I'm going to subtract 1 from both sides. That leaves me with 33 equals 3p. Now I need to get rid of that 3. That 3 is being multiplied by p. The opposite of multiplication is
Division.
So we divide both sides by 3. And you get an answer of 11 equals P. That means there's 11 plots for 34 boards. Gentlemen, Kenzie, focus, please. Yeah. Quick though. All right, we'll try another one. So this is a bead design for a necklace, has an arc shape with a repeating pattern. Complete the table of values. So we look at this. We got to figure out which one's the dependent, which one's the independent. For us, the independent would be the rows. Right? So like, how many rows do I want to build? If I want to do 10 rows, how many beads would that take? Or if there is 10 rows, how many beads is that? So my independent is the number of rows. The dependent is the beads. For my independent, I just count by ones. So 1, 2, 3, 4. My beads, I'm going to have to count on this one because there's no actual information given. So in row 1, there's 1, 2, 3, 4, 5, 6, 7. There's 7 in row 1. In row 2, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Row 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And I can figure out the pattern now. The pattern is that it's going up by plus 5. Now that we know the pattern or the relationship between these two variables, we can create an equation. The dependent variable goes by itself. So B is going to be by itself. It's the dependent variable. Equals five, and we're going to use letter R, right? 5R is a great start. It's 5R because the rate of change is 5, right? That's how much it's increasing by. And we multiply that by our other thing, which is R, our number of rows. But if you tried that, it wouldn't work, right? 5 times 1 row would be 5 beads. We need it to be 7. Yeah, plus 2. Right? It's plus 2 because I'm too short every time if I was to try it. That means I must have started with 2 beads and I'm going up by 5 every single time to add another row. That's much more realistic of the type of question you'll get. Right? They probably wouldn't even provide you with part A, which says create a table of values. That would be on you to be able to figure out on your own. It would just immediately say, here's some rows, here's some beads, create an equation. The way we create an equation is by creating the table of values. Now that we have the equation, we can answer all sorts of questions. So question C says, determine the number of beads in row 38. In any problem, they will give you one letter, ask for the other. They said row 38. That means R equals 38. You'll also notice somewhere in the question it'll ask for the other thing. So it said determine the number of beads. That means what is B? Yes, sir.
I just did 5 times 34 and then added 22 for row 4.
Yeah, that would work. I think. Let me see what the answer is. If you got the same answer, it should work. I think it should work. Yeah. I see what you're doing. So if we try this, I'm going to go to my equation. I'm going to change R to be 38. So I have B equals 5. Instead of R, I'm putting 38 plus 2. this thing can go in your calculator now. So if you tried it, you should get 192. Is that what you got? Awesome. So the answer is the number of beads would be 192. And again, they could make these questions bigger and bigger and bigger, right? They could say, how many is there in row 1005? You're not going to be able to do that pattern 1005 times. You're just not. So you're going to have to know mathematically what to do. Or they're going to start doing decimal values, right? So they'll say, instead of doing 1,000 rows, what if they did 10.7 rows? And then you're going to be stuck on how do I do a decimal value of a row? When realistically, you could just do the math side of it and get an answer. So you need to know the algebraic process. If you look at question D, they will always give you one letter, ask for one letter. In this question, it said determine the row. That means you're looking for R. Determine the row number in which there would be 92 beads. That means they told you B is 92. This concept of give you one, ask for one will work all the way through math. They have to. We go back to our equation. We change B to be 92. So I have 92 equals 5R plus 2. Your goal is to get R by itself. So I'm going to minus 2 as my first step. I subtract 2 from both sides. That gives me 90 equals 5R. Divide by 5. And you should get an answer of 18. So the row number would be row 18. I ran out of space there, but it'd be 18 equals R. Okay. I want you to try this one. Okay, so I want you to try to build the equation. That's the first step. Everyone's going to try it, then I'm going to do it. Then you can try parts B and C. But I don't want you to try B and C until we've all got the right equation. Okay, so try part A. This equation is harder than any other ones we've done. Okay, so if you were stuck and struggling, that's okay. You should have been stuck and struggling. It's the hardest one we've done. So if we're going to build an equation, the first thing I would definitely want to do is read the question so I know what's going on. It says a remote-controlled airplane is cruising at a height of 1,050 meters. It descends to land. The table shows the height of the plane every minute after it began to descend. The height of the plane changes at a constant rate. Write an equation that relates the height of the plane to the time since it began its descent. What you need to do is figure out the rate at which your dependent variable is changing. So I need to figure out how I'm getting from 1,050 to 975, and that should be the same way I'm getting from 975 to 900, which should be the same way I'm getting from 900 to 825, and so on and so forth. If you don't know how they're doing that, you need to either add or subtract a value. In this case, if you throw in your calculator 1,000, or let's go 1,050 minus 975, it will tell you that the difference between those two values is 75, which means what's happening every time is you're subtracting 75. And notice that it's a subtract 75. That's my rate. It's not just a 75. Remember that rate is our value that we use as our slope, which we're multiplying by the independent variable. So the start of my equation would look like this. The height, h, is equal to negative 75 times the time. That's my start to the question. I figured out the rate. I multiplied it by the independent variable. So that's h equals negative 75t. Now that doesn't make any sense if you were to try to calculate it. So if you, for instance, put in time equals 1 right now, that would say that height is negative 75 after 1 minute. Makes no sense. And the reason it makes no sense is because the plane didn't start at 0. It started at 1,050. And I know that because, one, the question told me. The other thing is it told me that when my independent is 0, so that means there is no independent, I have a plus 1,050. So that's how your equation would look. Again, if we think about this from what we've done in previous days, this value is my rate or my slope. This value is my starting point. Pardon? We're gonna. It's coming. It's coming. You said, imagine if you had to graph this, or imagine putting this on a graph. We are going to be able to graph these things. Yeah, definitely. So now that we all have the same equation, I want you to try part B and part C on your own. So give it a shot. Use the equation we just built together. See if you can figure out what letter they're giving you, what letter they're asking for. We built an equation. That's wonderful. Part B says determine the height of the plane after 9 minutes. I know it might seem silly, but on every single question, I want to identify what they're asking for and what they gave me. It says determine the height. That means I'm looking for h. After 9 minutes, that means they gave me time, t equals 9. It might seem tedious, but it is important that you have your variables straight. You know which one they gave you, you know which one you're looking for. Especially once the courses start to get a lot harder, because that's not always obvious. It's a little obvious right now for us. It's not always obvious come like math 11, math 12. So if I look at this equation, I'm going to change t to be 9 because that's what they gave me. I'm going to leave h as h. So I have h equals negative 75. Instead of the letter t, I'm putting a bracket and then 9, and then I'm closing the bracket. And then I'm adding 1,050. Because they gave me the independent variable, I can just calculate this. If I put that in my calculator, I do not know what the answer is. 375, thank you. People agree with 375? Yeah, see some nods around there. Good. Consensus wins, even if it's wrong. So that means the height of the plane is 375 meters after 9 minutes. When you get the independent variable, that's the easier one. The other one's the hard one because that's when they're giving you the dependent variable. For instance, C is a good example of it's not always obvious which one you know. If you read that, it says determine how long. All right, how long would be time? So I know I'm looking for time. In 1 second. Yeah, and I'll let you give it to me. Determine how long, so I'm looking for time, it takes the plane to land after it began to descend. If you read that question, it never gives you a height. It never says height equals 1,000. Height equals 100. It just doesn't. But somewhere in there, it must allude to height. It alludes to height when it says the plane to land. If a plane lands, what's its height equal? It's 0. Right? So this is an example of they have to tell you one value and they have to ask for the other, where it's maybe not obvious. All right. 14. How'd you get 14?
Well, the other one was 9 minutes, and then I just counted and added to 9.
So go up a minute, go down 75, go up a minute, go down 75. Yeah, that works perfect, right? So she said she figured out what 9 minutes was. She figured out, well, that was at 375. And if you just keep going down 75 every minute, you could figure it out. What's an algebraic process that we could use?
I was just gonna say how I answered it is I knew that 75 times 5 was 375, so I just added 5 minutes onto 9.
Ha, that's funny. Yeah, okay, that would work too, right?
I basically took the equation and then I put in like numbers for the time, and then kept like adding it up.
So you just kept testing it, like guessing and checking? That would work too. What's an algebraic process that would work for this question? And I want you to know there will be questions where it says algebraically solve. And as much as you guys all solved it, nobody used the algebraic process yet. So you're all right. So if it's multiple choice, numeric response, 100%. Written response, how do you do it algebraically?
You take 1,050 away from 0, which is negative 1,050, and then you divide 75 by that, and then that gives you.
You got it. So what she said was you're going to subtract away 1,050 and divide by negative 75, which is right. I'll show you the work that she's describing. So in any question, they gave you a letter, ask for a letter. They gave you H, go to your equation and change H to be 0. Leave everything else the same. So negative 75t plus 1,050. The algebraic process is this. You substitute a variable in, and then you isolate the other variable. Isolating means getting something by itself, which is exactly what Rachel was describing. She said you would subtract away 1,050 from both sides. 0 minus 1,050 is negative 1,050 equals negative 75t. That negative 75 is being multiplied by t. So the opposite of multiplication is division. So now I divide both sides by negative 75. If you do that, you get an answer of actually a 14, right? You get 14 equals t. That's how long it takes for the plane to land. This is the algebraic process to solving it. You will have to do it algebraically. Again, the questions that you're going to get to in higher grades, you have to do it algebraically. There will be no other process that works. The decimals will just get too hard. Yep.
I just have a question. It's not about maths, but why do we have the winter break? Those are whatever it's called like next week.
Cool. I'm going to rip through these last two because I think you guys just need practice / you're bored of me. So if we look at this question, this is a hard one because the independent variables aren't going up by 1. If you look at the independent variable, it's kind of sporadic. So it goes from 3 to 5 to 9. And we're used to it going up by 1. So when you look at the difference now, that difference doesn't accurately represent what's happening because it's not going up by 1 anymore. This one went up by 2. Hello, sir.
Big brain for a gym teacher.
Yeah. This.
Even a gym teacher.
Well, he's at everything. Well, sports pharmacy. He used to teach science and math, and he just changed.
Why would he go from something fine?
So if you look at the independent variables are going up by 2, and then it goes up by 4. Because Mary?
And you always say,
Because the independent variables aren't going up continuously, then the dependent variables are going to appear to not go up continuously. So if you look, to get from 275 to 425, we had to add 150. To get from 425 to 725, we had to add 300. So you'll notice it's actually not consistent growth. At least it looks like it's not consistent growth. But it really is. The way that you can figure it out is by dividing the growth on the left to the one on the right. So for instance, if I took that 150 and I divided it by 2, because there was actually 2 independent variables in there, it would give me growth of 75. If you took your 300 and divided it by 4, because the independent actually grew by 4, it would also give you 75. So the actual rate of change is 75. Yeah. This means my equation starts off with A equals 75 times H. Now, if you tried this, it doesn't work, right? Because it says that if you work 3 hours, you should get $275. So if you tried that right now and you said, okay, well, what's 75 times 3? You get 225. But it should have been 275. You're $50 short. The reason you're $50 short is because there was an appearance fee, meaning that there's like a starting rate to hire somebody. That starting rate is the $50 that you were missing to get to 275. Okay, so the rate is $75 an hour, but the starting appearance fee was $50. Remember that all these equations have a rate and they have a starting value. And you have to figure out what both of them are. If you look at part B, we already did this. Identify the hourly fee. The hourly fee is $75. We just talked about that. Determine the appearance fee. The appearance fee is $50. Awesome. If you read this question, it says a team is ordering hoodies and will pay a setup fee in addition to the $65 per hoodie. The following table shows the amount paid for the hoodies. Determine the setup fee. So that's all you're looking for is the setup fee. That's the same thing as saying the starting point.
can I help with this one?
Sure, talk me through it.
Is there anything?
Just talk through it.
If it's easier for me to explain that way instead of talking. So we did what we did the last one. We divide 405 by 5.
I think you're on the right track, but I have a different way that we could do it.
It would be 81.
Okay, let's try it. So you could do it a couple different ways, right? You could just realize that if it's $60 per hoodie, you could probably subtract your way backwards, right? And that honestly, that would legitimately work. But I'm going to show you another way that you could do it. The other way in which you could do it, Mackenzie, put the calculator down and then go sit. Thank you, sir. The other way that you could do it is by trying to use one of our equations. The equations that we've been creating have all been slope-intercept form. They've all been y equals mx plus b. Right? We've been doing that every question. We haven't been talking about it like that, but we have been doing it for every single question. We've had inputs, outputs, rate of changes, and starting points. This question wants you to find the starting point. The way I could find the starting point, which is b, that's my starting point, is by filling in values for the other three things. So if you knew an output, a y value, you knew the rate of change, m, and you knew an input, x, you could put those numbers in, and the only number left would be b. So I'll show you what I mean. We're going to use point 5 and 405 as our input and our output. My output is 405. That goes first. Equals m, which is my rate, times my input, which is 5. Plus b, which is my starting value. So I don't have an m yet. I didn't put anything in for m yet. But I filled in an output and an input. My m is my rate of change. The question told me my rate is 65 per hoodie, so I can go 65 right there. And you'll notice that you now have built an equation with only one missing letter. I use an input, an output, and my rate of change to create this situation. And now I can solve for b. The way I would solve for b is I'm going to have to calculate this. I'm going to have to figure out what 65 times 5 is. So that I have 405 equals 325 plus b. And then subtract away the 325. And that would tell you your starting value. In this case, your starting value should be 80. That means that was the initial cost, $80. Now, I understand that most of you guys wouldn't do that on a test, and I also understand you're probably not going to get questions that'll be hard enough that require you to do that on a test. But it is the mathematical process to being able to figure out a starting value. I think if that's a test question, people just subtract 65 until they're at 0 hoodies sold. That's my guess.
I did 65 times the number of hoodies sold.
Yep.
And then you gave me 325, and I just added 80.
Yep.
So I totaled that.
Yeah, that's like honestly the same thing. Yeah, it's just you doing it more logically, right? And that works. And that's how, for a question like that, that's all you would need to be able to do. Just kind of work yourself backwards. All right, last question here. It says a clothing store is having a sale. The table shows the regular price and the sale price of several items. Determine the equation used to calculate the sale price. Okay. To figure this out, you're going to have to figure out what's your input and what's your output. In this case, the regular price would be the input. And if you think about it, if you went to buy something on sale, say it's 30% off, then you would take the regular price and do 30% off it to get the sale price. So the thing you chose was the regular price, making the sale price the dependent event. Awesome. Our rates this time aren't adding and subtracting. Well, they might be. I guess we'll find out. If you go from 390 to 520, if you were to try to subtract that, let's see if we can find a pattern that way, because that's what we've been trying. And maybe it works, maybe it doesn't. That would be $1.30. If you went from 520 to 715, that's going to be $1.95. If you go from 715 to 975, That's $2.60. None of those things really appear to follow a pattern. Fair to say? I don't see much of a pattern there. They just kind of seem like random numbers. Awesome. This is because the rate of change isn't addition or subtraction. The rate of change is multiplication or division. That's how sale prices work. Yeah.
The historical pattern, if it increases by 65%, not from $1.30 to $1.95, but like from $1.95 to $2.60.
That's 65%. That's 65 cents. I agree, and that is 65 cents the other way too. You're right. But then the problem is these. That's going up by 2. That goes up by 3. That goes up by 4. So it's kind of like a double value on top of that, which makes it kind of hard. When you have a sale, sales are rates, right? It's multiplication. So when you get 30% off something, we'll do 50%. People are good at 50% off. If you have 50% off $10 item, how much would it cost?
$5.
Right, because you divided it by 2. Right? You didn't add or subtract, you times it by a rate of some sort. And that's what's happening with this question, which is why it seems sporadic. You're right, there is a pattern. And you notice it's like, well, it went up by 65 cents, but it's not an addition subtraction pattern because these things are going up at a weird rate. So instead, you have to try to figure out the percentage that something's increasing or decreasing. To figure out the percentage that something is going up or going down, we're going to have to use division. I'm going to need my calculator for this one. And there's different strategies to do this. So what I would do is I would actually figure out how much something's decreased in price. So for instance, if I looked at my regular sale price of the first item, what are we doing, socks? I would figure out how much the price has gone down. In this case, the price has gone down negative $2.1. It's hard to see. There we go. Zoom in a little bit. Better? It's decreased $2.10. I can then figure out the percentage that it's gone down by using that 2.1 and dividing it by 6, the original price. And if I do that, I get 0.35. I could do that again for every single price, and you'll notice I keep getting 0.35. So for instance, I look at $8. I say, okay, how did $8 turn into $5.20? Well, it decreased by 2.8. If I want to figure out my rate, I take that difference, 2.8, and I divide it by the original price, which is $8. And again, it gives me 0.35. And you could keep doing that over and over and over again, and you'd keep getting 0.35. I'll do another one for you. So the way it got from $11 to $7.15 is it subtracted by $3.85. And if you don't know, just do it in your calculator. I go 11 minus 7.15. If you take that difference, 3.85, and you divide it by the original price, you get 0.35. Because 0.35 is the discount that you're getting on all your stuff. This would be a 35% off sale. That's what that represents. mathematically, the way that we solve this is a little tricky. Because you don't just take the rate and multiply it by the price. As much as that would be wonderful, that's not how it works. Your equation this time will be that the sale price equals, and it's not 0.35, it's 1 minus 0.35 times the regular price. The reason why it's doing that, this represents 100% of the price and minus 35% off. So my real equation is S equals 0.65 R. That's a hard one. Probably a good life one though, because we all do sale prices. Yeah.